So this example is going to be a little bit different, but the same idea. Okay, so I want to let x equal something. I know that I'm going to need the 4. So uh, just like before, I know that when I square it, I need a 4. So this is going to be a 2. Okay, so I know it's going to be a 2. The problem is I have a 25 here, right? So I know that when I square x, so I need something here so that when I square this and x, I get 25. And so that tells me then that I need a 5 here, because when I square this term, that's going to give me 25 squared. That's equal to 4. Okay. Uh, so I will divide this term through, of course, but that's how I come up with, oh, when I have a coefficient in front of the x squared other than 1, I just know that when I finally square that term, it should equal that. Okay, so this would have been like 7, then this would have been the square root of 7x instead. Okay, I hope that makes sense. Um, all right. Okay. That should be a 2. Looks like a 4. Okay. So then I need to figure out what the trig function is, but for the substitution. So I'll go back to my original um, connection here, and I go, okay, so cosine squared plus sine squared equals 1. This has a minus sign in it, which means I need to subtract something, okay? But in particular, it looks like the x term is first, and unlike the previous example where the sign or the that it was a number minus the variable squared, this is the variable squared minus a constant. Okay, so that tells me then that it kind of has a similar form, but it's just slightly different. Okay, so uh, it kind of has a weird feeling. And so what that means is I need to do something so I can subtract over. So kind of like how we started off last time. Okay. Um, I'm going to have a uh, cosine squared theta equal to 1 minus sine squared theta. Okay. Kind of starting off in the same fashion. But this isn't the exact form that I need, right? So what if I divide everything through by um, cosine? So this is what we did last time. But to try a different route, since we're not having the same form, what we're going to do is subtract the cosine squared over and solve for sine squared. So if we get sine squared theta, what that's going to give us is 1 minus cosine squared theta. Okay. And so this is a different route than the one that we did previously. And so if we divide everything through here by cosine squared theta, okay, then you should start to see the form that pops out. So this is going to give me a tangent squared theta here, sine squared over cosine squared theta. 1 over cosine squared, that's our secant squared theta, or minus, and cosine squared divided by cosine squared is going to give me a minus 1. Okay, and so now if I look here, this is very much of the same form as the variable squared minus something squared. Okay, especially when you figure out, I'm going to factor out whatever that coefficients are so that this is a unit of 1 and a unit of 1 there. Okay, so that's also what's motivating this funky factoring here. So it looks, instead of being x equal to sine or cosine or tangent, in this case, we need x to equal some number times secant of theta in this problem. Okay. Make the substitution, then I'm just going to divide both sides by x here, or not by x, sorry, by 5. And so I get x is really going to equal 2 over 5 secant theta. And that tells me then that dx is going to equal 2/5. The derivative of secant theta is secant theta tangent theta, d theta. Okay. All right. So hopefully this is the right substitution. When we plug it in, again, we'll be able to determine that based on whether or not our resulting integrand becomes hopefully somewhat simpler. Okay. All right. So let's go ahead and plug in each of those pieces. I'm going to come down here for a little bit of room. I have an integral dx is all of this. So this is going to be 2/5 times secant theta tangent theta, d theta. Well, it doesn't start off well because you feel like it's getting more complicated, but let's keep going just for a little bit longer and see if it does make a difference. So I have 25, and then I have 2/5 secant theta, squaring that over 4. Okay. Squaring this, I'm going to get 4 squared over 25 squared. 25 squared, 25. So 4 over 25. The 25s are going to cancel. That's going to leave me a coefficient of 4. And I have 2/5 secant theta, tangent theta. D theta still on top. I'm going to have 25 times 4 over 25 secant squared theta minus 4. Okay, just like I promised, the 25s are going to cancel. They're reducing to 1. And then I have a common factor of 4. So if I pull that 4 out, this is going to simplify to secant squared minus 1. And just like we saw before, that's exactly what we wanted to give us a tangent squared. So this actually is what we hope for, is a tangent squared. And the reason why that's helpful is because it allows us then to say, I have 4 tangent squared. Those are perfect squares. I could take the square root of that, and it's going to give me a 2 tangent theta out. Okay, so simplifying that denominator. Right now, everything in the numerator is just coming along for the ride. I'm going to be left with a 2 tangent of theta on the top there. Okay, again, the square root with a tangent and then square root of 4 is giving me the 2. Square root of tangent squared is the tangent there. Okay, so then the 2 and the 1/2 are going to cancel, leaving a 1. And the tangent and the tangent theta are going to reduce. So this is just going to be the integral then of what I have, 1/5 secant theta d theta. All right. And so I think we saw that same integral in the last example, the secant theta part at least. And so we thought this was 1/5, 1/5, the natural log absolute value of its secant theta plus tangent theta plus some constant. Okay. All right. Just one more thing to do. Our angle, our integrand is our result here anyway, is in terms of theta, and our original one was in terms of x. So let's go ahead and go back to our substitution here. And I'll just make the triangle right here since it's close to where this is theta here. So secant theta is, again, this is equal to 1 over cosine theta. Okay. So if I kind of like think about multiplying and then dividing, what I see here is that cosine of theta is equal to 2 over 5x. Okay, so cosine is adjacent to over 5x, which means that the opposite side here is going to be 4 minus, sorry, is the hypotenuse is 25, x squared minus 4. Okay, so that's the missing part there. All right, so cosine is is secant. Well, we got that directly from here. So secant is going to be, so that's going to equal, yeah, so see the thing. Okay, so it's going to equal the natural log. I have a 1/5 in front. And I could pull it up as the power of everything, but it doesn't really gain us any traction. So secant is going to be, it looks like 5x over 2. Okay, so that's the secant part, and then plus, and then tangent is going to be opposite. Opposite, so that's going to be the square root of 25x squared minus 4 over the adjacent side, which is 2, and plus a constant. Okay. And so that is our final result. All right, I hope that was helpful, and I'll see you in the next video.